Okay, so in example 3, I'm showing you another real-world context about the values of a car after T number of months. Okay, so it's around the same idea as the previous question, but if you explore the equation, it has the V naught thing again. Okay, so let's explore the formula first. Okay, so this is the value of the car, and the value of the car depends on the number of months. That means the V will keep changing according to T. And then, so they already said that P is a constant. They already say that P is a constant. And V naught is the original value of the car. V naught is the original value of the car on the 1st Jan 2018. So is that a constant? Yes, that is also a constant. You think about it. The value, so if the value is like 60,000, so it will be forever 60,000 on that date. So it will not change anymore. Unless I change a date, then the value will change. So if you are referring to the specific value on the actual date, it's also supposed to be a constant. Okay, I got a little typo here, so it's 2018. So your job is to calculate the value of P. So your job is to find the value of P if on this date, right, the value of the car reaches 3/5 of the original value. Okay, so this one will be a bit confusing. So you need to be able to understand something first. So we are starting off on here. And then there's the value of the car is this. Okay, then so essentially this one is 4 years. So there's a difference of 4 years. So after 4 years, the value of the car become 3/5 of the original. So it drops in value. So after 4 years, which is very reasonable, like what I mentioned in example 2, the value of the car will depreciate after you use it. So the value actually become 3/5 of the original value after 4 years. So with this piece of information, your job is to find the value of P. Okay, so how are we going to find the value of P? Okay, so with the idea here that the value drop to 3/5 of the original value. So this V is my formula. This V is going to be my formula. So I'm going to like plug in the formula for the value of the car. So when I plug in the formula for the value of the car, I plug in with T equal to 48. Because after 4 years, so the value will become 3/5 of the original value. So I plug in the T equal to 48. And that is the value after 4 years. So the values after, so that means, right, this is the value after 4 years. And the values after 4 years is actually equal to 3/5 of the original value. So that's what the question is trying to say. So if you can understand this, you realize that it sets you for the calculation, because the V naught on both sides is a constant that can be cancelled. So V naught is a constant. So you can cancel the constant on both sides. And then you go for the ln both sides one more time. Okay, then you can divide over. So this question, for some people, this question is very direct. But if for some students, right, if you find this question, if you don't understand this question, most student, right, they couldn't do anything at all. They can't make sense of the equation, they can't make sense of the information. Okay, so I always find this question is a very extreme case. For those who have very good interpretation, straight away is a very short thing. Otherwise, the extreme case will be some students can't even start at all. And this was a O-level question. So it came out as one of it's quite an O-level question. So since then, it has been twisted around in exam with the same thinking. Okay, so this one is the O-level question that you can explore on the idea, but it also tested you on the technique, the learn both side technique, if you realize.